Hello everyone, my name is Klisa Corbaxhi and today I will be presenting my topic for my software architecture and design patterns presentation topic. It is the Memento design pattern. Moving on into the agenda for this presentation, I will be introducing the Memento design pattern, then going to talk about the intent of this pattern, the motivation for it, and then go into deeper understanding of some benefits and consequences. And then I will have the UML class diagram for the demo that I will be demonstrating at the end. And then I will take any questions or any comments. So intro to the Memento design pattern. What is the Memento design pattern? It's a behavioral design pattern. It falls under the behavioral design pattern category, which the main idea is to restore the state of an object to a previous state. It has the ability to save and restore the previous state of an object without exposing the details of its implementation. There are many uses for this pattern, but some of the main important ones are backtracking, for example, the graphing algorithms, log errors and events, and then also the undoing and redoing, which we will see later on. What is the intent of this pattern? It captures an object's internal state so that the object can be returned to the state this particular state later. That way, it does not violate encapsulation, which is a key object-oriented programming concept. So something that really helped me to understand was the computer game example. So we consider, for example, a computer game that goes on for a long time. For example, in a well-designed game, it is necessary to keep saving the state of the game periodically. This allows the player to undo a wrong movement if they did something wrong, or also to revert back to an earlier level and resume playing. Even in the beginning, I thought of, well, there's other ways to do it. It's not only this way, but we're thinking of this idea of a well-designed game where the object's internal states are not exposed, because by doing so, you would violate this particular concept, encapsulation. So this pattern, the momentum design pattern, externalizes the object's internal state in a safe manner by providing a mean for restoring object into initial state when needed. It also promotes undo or rollback to full object status. It undoes some mechanisms that lets users back out of some uncertain operations. The motivation for it is that it is often needed to backtrack when a specific path proves unproductive. It lets the user make full copies of an object's states, including private fields, and stores them separately from the object. This pattern also encapsulates a checkpoint capability, which is necessary to record an object's internal state. How does this pattern work? How does the momentum design pattern work? This picture right here is a good example that illustrates the basic idea of this pattern. So we have our three actor classes, or our main three entities, the three main entities. We have the originator, the memento, and the caretaker. The originator takes a private state and creates a memento, which is then stored into the caretaker that hands it back to the originator, and then the originator implements a restore. It will be a lot more clear later on when I go into the UML class diagram, but it is important to keep in mind that a memento's internal state can only be accessed by the originator, but the memento's object itself can be passed onto the caretaker object. Talking about some benefits and consequences of this design pattern, some benefits are to eliminate the need for redundancy, for multiple creation of the same object. It saves its state. So it provides a generic way to capture object state and store it somewhere else. It also provides a way of recording the internal state of an object in a separate object without the violation of the law of design patterns, as we talked about it earlier. The responsibility of memento storage is given to caretakers, which simplifies the originator class. We'll see in the demo how all three entities work out. It also discards the unwanted changes and restore it at a stable state. Some consequences are that it is expensive, it increases maintenance costs, and requires more storage. The saving and restoring state might be time consuming. And then some dynamic programming languages such as PHP, JavaScript, Python cannot guarantee that the state within the memento stays untouched. So the implementation, this is just a very generic UML class diagram, but it basically has the main three classes: the originator, the memento, and the caretaker. The originator class is basically all it does, it creates a memento object and uses it to save and restore. Then the memento entity stores the internal state of the originator object, inner class of originator and private. So it's common to use a constructor in order to make the memento immutable and pass it the data only once in the memento. So the memento, so that's the memento class, and then the caretaker class knows when and why to capture the originator state. It also knows when the state should be restored. So basically, this implementation right here, this UML class diagram, we see that the memento is nested inside the originator. By doing so, it lets the originator access the fields and methods of the memento, even though they're declared private. And then on the other hand, we have the caretaker that has very limited access to the mementos fields and methods, which lets it store mementos in a stack but not tamper with their state. This is basically my UML class diagram for the levels in a game. So I wanted a very generic, like a very simple demonstration of how the memento design pattern works. The UML class diagram here displays the three main entities. It has the originator class, the memento, and the caretaker. Think of the memento itself as the actual state. And then we have the originator, which only job is to create the memento. And then the third entity is the caretaker, where we will see that all the memento states in the caretaker will be implemented there. The caretaker will not have any way to modify the memento states, however. So going into the demonstration, the first class being implemented is the memento class. We have right here first of all, we create a private string and we call it level, right, for the levels. And then we have the constructor, which takes an argument and sets the current level, so this level to the coming level. And then, well, we also we need to use a wrapper for the whole, like the constructor. So we provide a method to get the level, which will return the current level. So we have public string get level and then return this level. And then we'll also have the public void set level string. We'll have this, which is needed because it takes a string parameter. So this is basically the whole memento class. All it does is it has the private string level constructor, and then we have the get and set level methods. The originator class is being implemented second, and that basically also has a string game variable which is private. The string called game, and it has a string called game, and then this game will be holding the current present game into the memento state. We'll also need the constructor originator, and then we'll have our set and get methods for the game, the set game, and then getting the game. And then we'll have the save method to save state to a memento class, which takes current game from the originator and creates new memento of it. We will also have the restore method that takes memento object and resets the current originator state. And this wraps the originator class. So basically all it has, the private string variable, we'll have a constructor, and then we have our set and get methods for the game, and then also the save and restoring methods as well. Now the caretaker class. As we mentioned earlier, the caretaker class will not have any way to modify the memento state. But this class has you will see all the memento states in here. So we have our public class caretaker, and then the caretaker class has a list of mementos, so that's why we have a private array list of mementos. Then we track current state in the list object, so that's why we have the private int current level equals -1. Then we implement a public constructor to initialize the list object. So this .list equals to new array list. And then we will also have the add method, add memento. So we need the method that adds a memento object to the list. So you see public void add memento, and then we gave it a name, res. This .list.add res. So far, the current state is only modified and stored into the index at which our most recent memento is stored. So that's why we need the current level equals this.list.size -1. We will also, in the caretaker class, have the get memento method, which will return a memento and then pass index to the list. And then our last main two methods are the undo, and then we'll see the redo later. Basically, same implementation. In the undo one, we'll have to do for the statement. If statement will be a little different than the redo. So the if statement in the undo is if current level is less than or equal to 0, current level is 0, and then return the memento. But if that's not the case, we return the memento for the current level. So we have the decrementation, so current level minus, and then return get memento of current level. The redo one is pretty much very similar, except we have the current list. So we're checking the overflow again. So if current level is greater than or equal to list.size -1, we return current level equals list size -1. Else, we decrement. So if that's not the case, then we return the memento for the current level. Then we have our main class. So in this class, what we're doing is we're creating an originator and a caretaker. So we're giving it create originator, get originator is assigned a new originator, and same thing for caretaker. And then this is just like a little test that will say, well, if the originator set game, if they are level 1, print get originator, and then if the originator set game level B, get caretaker will add the memento and save it, and then we'll print the level. Then after these, we'll have the undo and redo. So I will show you later. So first we undo. So if there's a level A and level B, if we undo it, it should go back to level A, and then if we redo it, it should go back to level B. So, and then the end is just the print level, just a method to get the printing of the current level. So as we see, we have level A and level B. So current level A, current level B, right? Then we're going to the third step and undoing it. So if we undo it, it should take us back to the current level A. And if we redo the level, it should take us back to the current level B. So that's basically the main idea of the Memento design pattern. Thank you so much. These are some resources that I used for this presentation. If you have any questions or comments or concerns, please do not hesitate to ask me. Thank you so much.